Good morning, everybody. Welcome back. Please don't forget to go and look for me under YouTube. There you have my information on the screen. Do a search under YouTube, and if you enjoy the videos that you are seeing, please don't hesitate to follow. Now, today we're going to do something totally different. What we're going to speak about is a very important device which is known as a Smith Predictor. These Smith Predictors are usually going to be referred to as classical control engineering techniques, which can be used to handle processes that are going to have very long known time delays. The whole idea is very, very simple. Instead of having the controller wait for a delayed feedback, the Smith Predictor uses a model of the process plus its delay to predict the current output, and therefore the Smith Predictor starts to operate immediately. Now, it is a model-based system, and therefore it is going to make use of a mathematical model of the plant without any delay whatsoever. And then it is going to have a look at a model of the actual time delay that we can encounter, and it's going to have a look at putting all of that together, and then we still are going to have a PID component. So from our point of view, we need to go and put in the model of the process, and that is going to consist of the gain of the process, the time constant, as well as the dead time, and we'll also go and put in a couple of PID values. By combining all of these, we'll be able to predict the present process state even when the real measurement arrives slightly late. So this is going to be used where dead time dominates your dynamics, whether it be in a chemical and a petrochemical process, or in an oil and gas pipeline, or a thermal system, or a remote or network control loop energy system. It doesn't make a difference at all. What you're going to do is you'll take the model, put it onto your process, and you will be up and running very quickly after that. Now, I'd like to call up my simulator, as one always does. And that is it. Very important that we do go and select the Smith Predictor. And if I was to go under the strategies that we are going to have, you will see that there is a strategy for a Smith Predictor. And I've gone and used that to do the operation itself. Now, as far as setting up the Smith Predictor is concerned, it's going to be pretty straightforward and easy. Put your controller into manual, run the process, and then we'll go and give it a step to see what the response is going to be. And I'm grabbing a piece of paper that I can write this down. My output is currently sitting at 35%, so I'm going to change that by 10% and take it up to 45% now on the line. So we're going to go from 35% to 45%. And I just want to go and have a look at the data monitor. It looks like my process variable is going to go up to 67.5. I can pause it and get that information. So with an output of 45%, I know that my process variable has gone up to 67.5. And with an output of 35%, my process variable was sitting at 52.5. Now we're going to write all of that down because we need to be able to calculate the right information. We've done all of this in many of our videos, so I'm going to keep it nice and simple and easy. Let's just go and copy that screen, maybe just copy what we have got and put that onto a blank page right over there. Okay, and now we can go and do what we have to go and do. Remember that the output would have changed from 35 to 45, so that change, that delta output that we would have been a value of 10%. My process variable would have gone from 52.5 to 67.5, so it looks like that change in the process variable was 15%. So you can go and calculate what the gain of the process is, and that's going to be the change in the process variable divided by the change in the output, and that should give us a value of 1.5. 1.5. Now hang on to that, because that's going to go into my Smith Predictor as part of my model. We also need to go and get the time constant. The time constant is the time taken from once the process variable responds until it gets to about 63.2% of where it's going. I'm just going to go and estimate that possibly as a value of 5 minutes. So let's go and put that down as 5 minutes. And then we need to have our dead time. The dead time is the time that elapses from when the output changes until I can see a noticeable change in the process variable. Once again, no rocket science that we're going to worry about over here. It's purely going to be a good guess, and it looks like it's going to be about 8 minutes to me. And I say minutes because my process is working in minutes. Now, at the same time, what you'd have to go and do is take that image and calculate what the PID values for that would be. In other words, the PID values, you can go and do something such as a Ziegler-Nichols open loop calculation using the calculations that we've already gone and covered in one of our videos, and that should get you up and going. So let's go back to our process, and I'm going to press the tuning button. And the first thing I do is go to setup. Now it's going to ask me what is the gain of the process, and we calculated this to be 1.5. It then asks us what the time constant was going to be, the TOR value, and I'm going to put in a value of 5. And it asks me what the dead time of the process is, and that's going to have a value, I think we estimated, of 8. Now I've taken the liberty of going to go and calculate the PID values for this process, and maybe we get a value of 1.11, and we're going to put in 5, and we're not going to put in any derivative because it's possibly going to be quite a fast process. And that is your Smith Predictor. If we put the controller into automatic and we start to run it, please have a look at how the output immediately starts to change. It doesn't wait for the delay to first come in. Yes, the delay is still there, but the output has already started changing based on the process. And that's the beauty of these Smith predictors. I'm going to take the set point up and have a look at how the output immediately starts to change, and then it works on all of the models that we have gone and put into the process. And that, in a nutshell, is going to be your Smith predictor. You know where my website is. If you would like to have a look at the great many different courses that I do present and get in contact with me, that is the link that you are going to make use of. Thank you for your time, and goodbye.